Today we're going to cover lesson 16.2, and we're not going to use the book because the book has two examples which are already worked out for you, and then they don't give you graphs. So we're going to walk through a note sheet, but lesson 16.2 is about graphing inequalities in two variables. So a learning target is graph on a coordinate plane the solutions of a linear inequality in two variables, and those variables are usually x and y. And if you remember from first trimester, an inequality is less than or equal to, greater than or equal to. And then we're going to interpret the graph of the solutions of a linear inequality in two variables. Okay, so here are the examples from the book that we're going to skip, and we're going to jump straight to this note sheet. So let's fill this in together. So a solution to a linear inequality is all of the ordered pairs so parentheses x comma y, that's an ordered pair, that make the inequality true. Or if we're looking at our graph, this would be the shaded region, the solution region. So what we need to do is determine which ordered pairs are solutions to the linear inequality below. So you should see 2x minus 3y is less than 15. So what we're going to do here is we're going to take this x and y, and we are going to plug them into the inequality above. And the inequality above is in standard form. Ax plus by is less than c. So what we're going to do is we're going to take this 2 and substitute it in for x. We're going to take this 5 and substitute it in for y. And we're going to do that for all of these ordered pairs. Okay, x goes in for x, y goes in for y. So if I write it out, I'm going to start with the 2 that's given, and instead of having an x, I'm going to replace x with 2 minus 3 times y, and I'm going to replace y with 5 less than 15. Now we can use our calculator here, or we can break it down step by step. Okay. 2 times 2 is 4 minus 15. 4 minus 15 is negative 11. So this says negative 11 is less than 15. Remember, our alligator mouth or our Pac-Man mouth wants to eat the bigger number. So is this a true statement or a false statement? This is true. So what that means is the ordered pair 2, 5 is a solution. It's an answer. It's in our shaded area. Okay, now let's do it again, but we're going to plug in negative 1 and negative 7 this time. So we're still going to start with the 2, and it's 2 times x, but x is coming out and sitting on the bench, and it's being replaced by the negative 1 minus 3 times negative 7 is less than 15. You can type the first part into your calculator as one big problem. 2 times negative 1 minus 3 times negative 7. Or you can break it down into two different parts. When we type that in, we get 19. because it's negative 2 plus 21, so 19 is less than 15. Is the Pac-Man mouth eating the bigger number here? No, it's not. 19 is not less than 15 or smaller than 15. It's greater than. So this is a false statement. So -1, -7 is not a solution, or it's not an answer. It's not in our shaded area. All right, I want you to try the next one. You can do it. Plug in 3, -4. So this is 6 plus, because 2 negatives make a positive, so plus 12. 6 plus 12 is 18. Is 18 less than 15? Is the alligator mouth eating the bigger number here? No, so this is a false statement. Go ahead and try 0, 0. Take out the x and y and replace them or substitute them with 0. Anything times 0 is just 0. So this becomes 0 minus 0. So it's just 0. Is 0 less than 15? This is a true statement. So what that means, 0, 0 is an answer or a solution. It's in our shaded area. So this is going to help us a little bit later when we are graphing these. Okay, so let's move on to the steps on how to graph, okay, which is why we did a graphing review or a graphing practice earlier this week. Graphing linear inequalities is a way to show all of the ordered pairs that are solutions. So below are the steps to graph. So step 1, if necessary, we are going to put the inequality in slope-intercept form. So the inequality that we were just working with was in standard form, and we can't graph it that way. So down below, we're going to have to convert it to slope-intercept form, which means that y has to be by itself. And just a reminder from first try, if we multiply or divide by a negative number, we have to flip our inequality symbol. We have to make it go the opposite direction. Change it or reverse it. So after it's in slope-intercept form, y is less than mx plus b, or y is greater than mx plus b, then we're going to plot the y-intercept on our y-axis, and we're going to use the slope to plot multiple points. So we want to cover our whole coordinate plane with many points. Then when we connect these points, we're going to use a solid line if we have less than or equal to or greater than or equal to symbols. And we use a dashed or a dotted line for less than or greater than symbols. Then step 3, we need to shade. Okay, we need to shade either below our line, above our line, to the left, or to the right of our line. So what we need to do is choose a test point that's not on our boundary line. And the easiest point to plug in, if we look back above, the easiest point was 0, 0, because anything times 0 is 0. They kind of cancel out. So I always choose 0, 0 if it's not on my boundary line. If the result is true, so if we plug it in, it's a true statement. What that means is 0, 0 is a solution. So we're going to shade the portion of the graph, or the half of the graph, that includes that 0, 0. We're going to shade towards 0, 0. If we plug in 0, 0 and we get a false statement, then 0, 0 is not a solution, so we're going to shade the opposite way, away from 0, 0, so we do not include it. So we're going to graph the example that we dealt with above. The 2x minus 3y is less than 15. Okay, this is in standard form. It's not in slope-intercept form yet. So we need to convert it to slope-intercept form. So it looks like this, so that y is completely alone or isolated. We want y all by itself. So my first step here is to get this negative 3y alone. So what should we move? We want to move the 2x, and it's positive, so the opposite is to subtract 2x. So this cancels. Bring down the negative 3y in my inequality symbol. And then 15 minus 2x, those are unlike terms. One's a number and one's a variable, so we're going to keep them separately. But I want to write my mx term first and then my plus b. And if I look, y is not alone yet. There's a coefficient in front of it. There's a negative 3 out in front. So negative 3 and y are being multiplied. So the opposite is to divide by negative 3. Whatever we do to one side, we have to do to the other. And our notes just said if we divide by a negative, we flip our inequality sign. So now our alligator mouth wants to be facing or eating the y. Negative 2 divided by negative 3. Two negatives make a positive. 15 divided by negative 3 is negative 5. And now this is in slope-intercept form. What is my y-intercept here? My y-intercept is negative 5. So on our y-axis, we're going to count down 1, 2, 3, 4, 5. So all the way here at the bottom. And then our slope, our rise over run, is a positive 2/3. So remember, if we have a positive slope, we want our line to be increasing, inclining from left to right, going upwards. So from my y-intercept up to over 3. And I can only put 2 points on this graph because I'm running out of room. And if I'm looking at my inequality symbol, this is going to be a dashed or a dotted line because I do not have an or equal to line under there. So watch how I'm going to do this. We're going to just make little dashes. Dash, 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 dash. Okay, and make it obvious, especially when I'm grading a homework quiz or a test, that I can tell that they're dashed. If you're using Cami, try to find the dashed line. If not, use your mouse the best you can. So I've done step 1 and step 2. Now step 3 says choose a test point not on the boundary line to figure out where to shade. Well, we actually already plugged in all of these points. So 2, 5 is a solution. 0, 0 is a solution. Okay, but let's practice again plugging these in. So 0, 0 was an answer. and 2, 5 was an answer. But let's practice one more time how we do that. So I'm going to test 0, 0 because it's right here. It's not on my line. So what that means is x and y are being replaced by 0. Okay, so 0 instead of y is greater than 2/3 times 0 minus 5. Anything times 0 is 0, so those cancel. 0 is greater than negative 5. Is 0 bigger than a negative number? Yes, that's a true statement. So what that means is 0, 0 is a solution or an answer, so we're shading to include 0, 0. So take your pencil and you're going to shade this entire portion of your graph. And make sure I can still see that your line is dashed even after you've shaded. And if you remember from above, when we plugged in 3, negative 4, we got false. It's not a solution. So look, it's in the white area. It's not in my shaded area. Go ahead and turn your paper over. We're going to look at question 1. Step 1 says to convert this to slope-intercept form, but it's already in slope-intercept form for us. So we're going to plot our y-intercept, which is down at negative 5. So from your origin, on your y-axis, count down 5 boxes. Then we're going to use the slope to plot multiple points. Now my slope, or my rise over run, is 1 over 3. So I'm rising 1 and I'm running 3. And I know that I had to go in this direction because it's a positive slope, so we want our line to be increasing. And this is going to be a dotted or a dashed line. So go ahead and connect it. And then the easiest point to choose to plug in is 0, 0. And I know I can plug it in because it's right here, which is not on my boundary line. Okay, so what that means is we are going to take this 0 and plug it in here for x, and take this 0 and plug it in here for y. So 0 is greater than 1/3 times 0 minus 5. These cancel. Is 0 greater than negative 5? Okay, if you think about your number line, here's 0. These numbers over here are negatives. These ones are positive. So yes, 0 is always going to be greater than negative numbers. So this is a true statement. So what that means is I'm shading towards this 0, 0 point because it's a solution. So you're shading this portion or this half plane of your graph towards the 0, 0. Okay, let's do one more question and then we'll be done for today. This is already in slope-intercept form. So let's go down to -1 and plot our y-intercept. Our slope is a -2/1. So because it's negative, my line needs to be decreasing or declining. So I'm going to go down 2 boxes, that's my rise, run 1, down 2/1. Then we want to go up 2/1 the other direction. And this is going to be a solid line because we have an or equal to. So take your ruler and I want you to connect these with a solid line. And then we're going to take that 0, 0, and we're going to plug it in to test where we need to shade. So 0 is replacing x and y. Now, if you want to, you can take this and plug this into your calculator, or you can remember that anything times 0 is 0, so this basically cancels out, and 0 minus 1 is -1. So is 0 smaller than a negative number? Think about your number line. No, this is a false statement. So what that means, 0, 0 is right here. Okay? It's not a solution or it's not an answer. So we need to shade away from 0, 0, the opposite way. So I'm shading like down to the left of my line, over in this direction, this half plane of your graph. Away from your 0, 0. Because 0, 0 is not an answer, so it's not in our shaded area. We will finish this worksheet together later. So we're going to stop right here with question 2.